Assalamu alaikum. Today's topic is the question number 5. Find the value of x which corresponds to a standardized value of minus 2.05 and 0.86. Both of these values are the z values for each of the following distributions. First part having the mean 62.3 and standard and variance as 38. Z, we know that the standardized variable is equal to x minus mu over sigma, and de-standardizing expression will be x is equal to mu plus sigma z, where x and sigma z both are the values of the variables. Z is the value of standardized variable and x is the value of normal variate x, which is normally distributed with mean 62.3 and variance 38. So x and z both are the values. Now we substitute the values of this given uh, statement. Minus 2.05 is the value of z, 0.86 is the value of z. We are going to substitute both of these values one by one in this expression along with the mu and sigma under root 38. Look into the graph first. In the middle, there is the mean of the x variable, which is 62.3. If we plot one more line here for the z, which is parallel to x-axis, for example, it starts from minus infinity to plus infinity, and we are writing it as its value is z, this one, and the values on the z are the points which is on the negative side, so it must be minus 2.05, and 0.86 is positive, so it is on the right side of the zero, which is here. So these are the 2 points given on the z scales. In the middle there is the point 0, so 0 is in the middle. Parallel to x scale, there is the mean mu, which is 62.3. So 62.3 is on the upper scale, and on the lower scale there is 0, and on the left hand side of the 0 is minus 2.05, and on the right hand side of the 0 is 0.86. So for these two values of z, we have to find the expressions of x, simply the expressions of x. So we substitute the values in this expression. Mu is 62.3 under root 38, because 38 is the variance, so standard deviation would be under root 38, and first value is minus 2.05, and in another expression we will substitute 0.86 to get the second value of x. So these are the two expressions. We can solve them and get the values on the x number line. On the z scale, we have given the values, and corresponding values on the x scale we can get from these two expressions. In the second part, mu and sigma square both are not given. Look, mu and sigma square both are unknown values, so we will get the expression for x in 62.3 is replaced by mu, under root 38 is replaced by sigma, and minus 2.05 and 0.86 will be there. So in the next part, you can see the expression are this one. Mu and sigma are unknown, that's why we cannot put them. We are just replacing the z values in the expressions and get the results for the corresponding x. In the third part, next one, in which mm, this one, a and b are given. In this part, a and b are given. So a and b are replaced instead of mu and sigma square. So a is in the replacement of mu and b is the variance. So under root b is the standard deviation. So simply just these are the expressions you can write for the solution of this part. And next is 5b. In this question 5b, if x is normally distributed with 100 is the mean and 64 is the variance, then find the value of a such that probability x less than a is 0.95. In our expression, uh, probability x less than a is 0.95, which shows that the area below the point is 95%. So a must be on the right tail because the total probability under the curve is 1 and it starts from minus infinity to positive infinity. If it's minus infinity to going to the positive infinity, but before positive infinity, the area is 0.95 and up to plus infinity area is 1. So before 1 it should be here at the right tail. So a is on the right tail and below this point all the area on the left tail is equal to 0.95. For example, if I place a number line here parallel to x scale, this one, this scale is for z, we will write it here, it's z, capital Z, always write capital X and capital Z for the variables. In the middle of this point there is a point 0, so we can write it here, this point is 0 on the z scale and a is on the right tail, so we can place a line here and on the x point the value of this line is a and parallel to z we don't know what is the value, so initially we have to find the z value and then the area which is given here is 0.95. So below this point the area would be shaded, for example this area below this point would be shaded and its value is 95% or 0.95. I use this zigzag so that it's easy to shade it. So this area, shaded area is, in our case is 0.95, 0.95. So this is the area, shaded area. This one 0.95. Then the above area is 0.05, which is not shaded on the right tail. So probability x less than a is equal to 0.95 is converted into z first. X is replaced by z and a is converted into z by subtracting 100 and dividing by 8. So a minus 100 over 8, the value of z, and is equal to 0.95. We just place the x into z and a converted into the Z's standardized value. Whenever probability is given, probability z less than, we can write it as phi, capital Phi. So this is replaced by capital Phi in the next step. Now phi is on the left hand side. Whenever it goes on the right hand side, it should be phi inverse. So we can write it as phi inverse of 0.95. And using the table 10a, which is on the page this one, 295, we will locate our probability under the column P, the 0.95, which is not on the first page, not on the second page, and the third page. We can see the value is 0.95, which is here corresponding to the Z 0. 0.950 is 1.6449. In the next step, we will replace phi inverse of 0.95 by 1.6449. So A minus 100 over 8 is equal to 1.6449 is solved for the value of A, and the result is 113.159. Obviously, in the figure, in the center, the mean is 100. We can write our mean. If we place 100 here, then its value will be here 100. This is our value of the mean 100. And 113 is on the right side because A is on the right tail, so 113 should be greater than 100, and it is greater than 100. Therefore, our answer is verified by the figure. 5C, the third part of the question. If X is normally distributed with mean 60 and variance 25, then find the value of A. This A is actually should be in single quotes. A such that probability X greater than A is 0.837. So first look in the figure. A is on the left side because above this point probability is 0.837. In this middle, half area is on the right tail, half area is on the left tail. If half area is on the left tail, so 0.5 is the probability of this area from starting from middle up to this point. Its area is 0.5. But if we include some more area, the probability is now 0.837. So it should be A should be on the left side of the zero line of the middle line. So A is here. But in our case, probability is given for the greater than X greater than A, this one. But our table is for the phi, which gives you the value shaded area under the point A. This shaded area is given in the table. So we will convert our figure in such a way, for example, this area. How can you get this area? This area would be definitely obtained by subtracting 1 minus 0.837. 1 minus 0.837. So this area is here. Okay, this is unshaded area which is given in our table. So if we understand this concept, then come to the solution. Mu is equal to 60, sigma is given as 5 because variance is 25, so sigma would be 5. Our standardized value is standardized variate is z is equal to x minus mu over sigma. So at x is equal to a, because a is the value on the x-axis and corresponding value on the z scale is this one. First of all, we have to find this value of z, and z is equal to a minus mu is 60, sigma is 5. So we replaced all three values in this one. So this value is here, a minus 60 over 5. Now we will convert the given probability x greater than a is equal to 0.837 in terms of z. Look, probability x greater than a is equal to 0.837. X is replaced by z. A minus 60 over 5 is the value of z is equal to 0.837. Since its value is for the greater side, but R phi is for the less, we will replace 1 minus this one and 1 minus, we are subtracting 1 from both sides. So 1 minus probability of z greater than is, now we can write it as probability z less than, and 1 minus 0.837 is equal to 0.163. So now the expression is in the standard form, and probability z less than can be written as capital phi of this expression is equal to 0.163.
मैम स्टूडेंट्स कह रहे हैं कि हमें ऐड
Next,
करके
phi inverse 0.163 is as we have done in the previous part of the question, that we used table number 10a for phi inverse. So again we are
मैम
using
स्टूडेंट्स कह रहे हैं ऐड कर
this table is 10a 0.163. We will locate this value here 0.163. Okay, 0.16 is here under the 0. This is under 1, 2, 3. This is 0.163. Phi inverse gives us minus 0.9822. So we will substitute this value in our expression, which is minus 0.9822, and solve this expression for the value of a. So 5 would be multiplied by this one, and 60 is minus 60. Whenever it comes on the right side, it would be plus 60. So plus 60 plus 5 into minus this expression, and the answer is 55. From the figure, we observe that A is on the left tail. In the middle, there must be the mean. And the mean of the distribution is, in this part, 60. Its value is 60. So we will write here the value 60. If 60 is here, then our answer must be below 60. That's why the answer we got here is 55 mm, 55.089. Okay, so 55.089 is the value of A, above which the area is 0.837, which is the given condition.